DynamicISP, Dynamically Control Image Signal Processor for Image Recognition. Do you know Image Signal Processor, ISP? It converts raw image sensors output into sRGB images that humans feel natural and beautiful. Typically, ISP consists of many static functions like these functions. It is known that current image recognition DNN needs ISP as their preprocessors. sRGB input to DNN rather than raw image get higher accuracy. Usually, ISPs are statically tuned for human eye by experts. Our questions are images suitable for human eye and DNN the same? Also, are the same ISP parameters the best for all the environments? So we try to control ISP parameter dynamically based on what the downstream recognition model felt. For example, DNN detector felt the stairs are too dark to see. Our controller extracts the information from intermediate feature of the DNN and convert into how to control ISP parameters for the next frame. Neural AE is a good baseline which controls auto exposure function, a simple multiplication function with the similar idea. However, ISP is difficult to be controlled due to complex function with local minima and multiple layers and multiple parameters instead of single layer with single parameters. So we propose three methods to achieve ISP control. One is residual output format of parameters. We decompose the control into static tuning to average good parameters for the entire dataset and further pursuit of the best parameters per image. Two is the difficulty of controlling complex function. The second is latent update style controller. The semantic feature branch estimates a latent variable containing how to process with the entire ISP, and then after applying each ISP function, the latent variables are updated to contain information on what the remaining function should do. By doing so, we achieve the control of multi-layer functions. The third one is parameter initializer. At the training, we memorize the recent controller's output in a buffer and randomly use the variable at the first frame. It realizes necessary and sufficient scenario of environment change. These are evaluation results on human detection tasks in wide variety of environments, including dark, HDR, and handshake. The upper row is our baseline controller. By adding our proposed method, we can successfully control complex ISP parameters. Compared with previous results, our method achieves the highest accuracy with small computational cost. We also evaluate with LOD dataset, which collects dark images for detection task. As you can see, our method exceeds previous state-of-the-art method by large margin. Finally, we show an example smartphone application. The upper is processed with a smartphone's hardware ISP. The lower is our dynamic ISP. For this application, dynamic ISP is trained with pseudo-raw images converted from COCO dataset instead of real raw images. In fact, it affects accuracy, but still better than the hardware ISP. The right video is an analysis with slow motion using a different smartphone. When the light is turned on or off, the first frame is failed to detect due to sudden environment change and bad ISP parameters. However, our method controls properly within one frame and detects me in the next frame. To sum up, we propose a method to dynamically control ISP per image, which is lightweight and beneficial to the downstream tasks. Thank you very much for listening.